So I noticed there was a mistake on the paper printed schedule for this talk. So if you're here for the progressive web app talk, then sorry to disappoint you. I won't be talking about that. And I won't be disappointed if you switch to another channel, but please don't. So welcome to the state of in-app purchases on Android. Again, I'm Sebastiano. I am an Android and GDE, and I'm also an engineer at Clue. Just a few words about the company. Clue is a health app and a platform that provides empathetic and science-based information about female health. And Clue is also hiring. So if you're keen to know more about the topic, if you're interested, or if you just want to work with me, it's totally fine. And if you're looking forward to moving to Berlin, which is, one of the hottest and coolest cities for the startup world right now in Europe, then be sure to talk to me after the presentation. Hopefully you're going to like it. And we do this and much more at Clue. So without further ado, I think we can begin. So whether you work for a very successful company already, like a very established company, or you work for a startup that has just done their first steps into the tech world, at some point, you're going to ask yourself this question: how can we continue to provide this great service that we're providing already to our users in a sustainable way? So how can we make money out of the product that we provide so that we can keep providing it without having to contribute to the costs of maintaining this product only on ourselves? And since we're all Android engineers, the question is, well, sure, but also how do we do it on Android? So yeah, actually, how can we make money on Android? That's kind of a catchy title, like clickbaity, but sorry. So thankfully, the Android ecosystem, the Android framework, provides with tools to do that. And these tools are called in-app products. In-app products divide into two categories. The first one is called managed products, and the second one is called subscriptions. So we're going to dive a little bit into the details of these two just to understand what we're working with. Let's talk about managed products first. So managed products, you can think of them like something that you buy just once. Like it's something that you pay money for, you get something in return, and that's it. Each application can, of course, offer multiple of these managed products. Like, I don't know, if you think about a game, for instance, that has an in-game currency like coins. You could decide to buy a small bag of coins because you want to, I don't know, advance faster in the game, or because you want to buy this cool new armor that has just came out. Or you can buy like a medium-sized bag of coins, or a large size. You get the idea. So each application can offer as many managed products as the developer wants. But also, there's another dividing into two categories within managed products, because they in turn split into two: consumable managed products and non-consumable managed products. And the difference can be explained like this. So consumable products, again, let's go back to the example of the small bag of coins. You can decide, okay, today I want to spend 10 coins on this item, and I still have, I don't know, 90 left. But tomorrow I want to spend all of them into something else, which is way cooler. And then I finish the small bag of money of coins that I bought, and the product ceases to exist. I consumed it all. I can do it partially, I can do it completely. It's up to me. But once the product is fully consumed, that it's no longer available to you. And non-consumable products, on the other hand, work in a different way, because you buy them and they stick to you for the lifetime of the existence of the application. So the first example that comes to mind is Action Launcher, for instance, on Android. So there are many launchers, and many of them offer the Pro upgrade to unlock new features. And in case of Action Launcher, you can pay, I think, €5 to unlock the features, and that purchase is a managed product. It's non-consumable because it doesn't expire, it doesn't erode, so you cannot do anything with it other than possessing it. And that unlocks the feature for the entire lifetime of the application. So these are managed products, and subscriptions, on the other hand, work in a different way. So the point with subscriptions is you're fairly familiar with the concept. So they are recurring. So you buy the subscription today, and it has a duration. Let's say it's a monthly basis subscription. So what happens is that after 30 days, your subscription is about to expire, but it gets renewed. And so that's every 30 days with the original amount of the subscription. And again, an application can offer multiple subscriptions at the same time. So I don't know, there can be one subscription for this feature, and there can be another subscription for another feature. Each one of those can have different durations and so on. The cool thing that not really many people know is that you can also move across different subscriptions. So I don't know if you are on the 6-month subscriptions for this feature and you decide, oh, wow, that's cool. I want to save my money for next year, so I want to upgrade to the 12 months one. Then you can definitely do it as long as the developer allows for it. So it's a feature that needs to be provided by the developer. It's available from the in-app billing system, let's say. And it's very convenient. And that works as well for the downgrading of subscriptions. So if you feel like this is too much for you, then you can definitely change and switch to a much lower priced one. And the other thing is that subscriptions are auto-renewed. So there's no need for you to remember, oh, damn, tomorrow my subscription for this awesome service ends, so I need to renew it manually. I need to, I don't know, go to my mobile device, press renew or something. No, that's all taken care of automatically by the system, by the framework, let's say. So there's no need for you as long as you have credit in your payment system of choice. So this is just like the panoramic view over what we're going to be working with. And just at a glance, it looks like this. So managed products, one-off payments, they can divide into consumable, non-consumable, whereas subscriptions are recurrent billing, can have different durations. So I don't know, weekly, monthly, 6 months, 1 year, even seasonal. So if you're, I don't know, a sports fan, you want to provide a seasonal pass, it's supported by in-app billing on Google. And of course, they are non-consumable by default because you cannot do anything with a subscription other than possessing it for the lifetime of the subscription itself. And then there's another thing that we need to frame precisely. So to identify one of these in-app products, we need to use product IDs. Sometimes you are going to see like this code, SKU. It stands for stock keeping unit, I think. But what it is in practice is like the identifier for each product. It has to be unique, so that's really important. And if you try to create one in the Google Play console, this uniqueness is going to be enforced by Google itself. So if you try to use the same one for another product, they're going to warn you, no, you cannot do that. And with this introduction done, so we know what we're going to talk about, let's delve into a little bit more the details of implementing in-app billing on Android. But before we do that, I would like to take you to a journey and to visualize a timeline of the past 5 years. So in-app billing was first launched in 2011. So on that day, it was like the 29th of March, more or less. Finally, developers could provide purchases from within their app. So there was no longer the distinction between, oh, is this a free app? Or, oh, is this a paid app? No, there's the freemium model coming in, which is big news, right? And shortly after that, like probably less than a year, Google announced the availability of the in-app billing APIs version 3. And it's just like an iteration of the set of APIs, so nothing to write home about. But then, after that announcement, days passed, and months passed, and years passed, and nothing was happening until one fine day in June of last year, 2017, where Google announced, like as a surprise, the availability of a developer preview of the new Google Play billing library. And shortly after that, this developer preview was graduated to version 1.0. I think it was September. Yeah, September. And you can, given this time frame between the 10th December 2012 and 12th of June 2017, it's almost 4 to 5 years where nothing happened in the in-app building world. So you can imagine how big this news was. And given this, let's first understand what we're talking about when we speak about the in-app building framework. So at a high level, there's one basic requirement for you to use in-app building, and that requirement is the fact that your Android device needs to support to have building capabilities. And what that means is that it needs to support Google Play services. It needs to have the latest version of Google Play services, run the Play Store, and so on and so on. But how does that work, actually? That works because given that you have Play services installed, you're going to have a service running on your device that is called in-app building service. And in turn, for us developers to communicate with that service, we can use an interface definition file called inappbuildingservice.aidl. And that interface defines a set of methods that are then implemented by this service. And what libraries do is just wrapping this interface into something just more API-friendly for developers to use. And that's all it takes to understand what in-app building is all about on Android. And we mentioned before that up until last year, we only had this in-app building version 3 set of APIs. So let's see in more details what is that about. So actually, there's nothing to talk about because what is called in-app building version 3 is just the AIDL file. That's it. So we were given this set of methods that allow us to bind to this service and say, OK, go and implement everything on your own. And we can see the list of methods that this interface file provides. Things like, I don't know, is building supported on this device? Or please give me the buy intent for me to purchase a product that has this product ID. Or give me the list of purchases done by the user. Consume a purchase even. So we only had this thing to work with, which is not much. And you could argue, well, there are advantages in using this approach. And one advantage could be, well, it's pretty simple to understand because we're using intents and bundles, so everything we're already familiar with. So it's not really much to having to understand. However, if you start thinking about it, like if you need to implement this on your own, then you start saying, OK, but some of the methods are synchronous, and they take a long time to operate. So what do you do about that? Well, actually, then you need to take care of making those methods asynchronous. So you need to wrap them. And that adds a little bit of extra work on top of what you already have to do. And then you start thinking again, oh, but actually, it's not type safe because we're using bundles and intents. So the passing of the objects within these containers is just strings because that's what the building service really gives us. Like the receipt for a purchase is a string that contains a JSON structure with fields inside that we need to parse and then need to enforce the type safety at a different level of the hierarchy. And then again, you start thinking and say, oh, but actually, it's a service, so we need to persist this connection. We need to keep it alive. And what happens if the connection is disrupted? We need to take care of it and restore it in some way. And also, the documentation for this is non-existent. So maybe some of you remember we had this trivia drive sample on Google Code, I think, that is now on GitHub. And that was the only kind of documentation that we had. So we were given an implementation of these APIs. And we were just told, OK, just copy-paste this and put it in your app. So you can imagine how safe this could be considered. On the plus side, we were given this thing called IAB helper. It was a Java class with a bunch of utilities that was doing some of the work for us, like turning something into, like turning the synchronous APIs into asynchronous versions of those. So we were, it wasn't that bad, but it was still something we could improve, definitely. And entering the new Play building library. So it was announced really, really recently, just last year. And if you think about it, it really replaces nothing because we didn't have anything before other than the interface. So the fact that Google published this library really means something because we no longer have to do all the work ourselves. We can rely on this library. And it's maintained by Google. So it means that every time they publish a new feature or they introduce a new capability, then it means, OK, so I don't need to do anything other than updating the library. Whereas before, with the trivia drive sample, you had to continuously check GitHub and say, oh, they introduced a new property, actually. What is its name? How do I find it? Oh, how do I interact with it? And so on. So it wasn't really a pleasant experience, where as of now, you just, I don't know, update the dependency on Gradle, and you're done. And what it does, this library does, is really simple. Like, it offers just nicer APIs on top of the interface to work with. And in going into more details, the components of this library are very simple because actually there is only one class that we interact with, which is called billing client. And the billing client makes use of different listeners for depending on the things that we need to do. One listener is the billing client state listener, and is the one that we use to monitor the state of the connection to the InApp billing service. So whenever the connection is established, we're going to get a callback. Whenever the connection drops, we're going to get a callback, and so on. And at the same time, we have another listener that is called purchases update listener. And this is going to be triggered whenever we either complete successfully a purchase on behalf of the user, or if the purchase procedure didn't go well, then we get a meaningful error that tells us, oh, but actually this thing happened, so we couldn't go through with this. And it's actually very simple. The billing client, when it comes to the methods that it offers, is pretty similar to the ones that we saw in the interface file. And that's a good thing, because we are already familiar with what we need to do. But if you look carefully, there are some little improvements here and there. So you can perhaps tell that there is now the builder pattern enforced, which is much nicer to work with. You can set listeners for different things. So we have the set listener for the purchases. Whenever we start the connection to the service, then we need to provide a listener to understand when it's ready, when it's not. And some of the methods are marked explicitly as async. So you're going to need to know, oh, well, actually, this is going to take time, so I need to provide a listener for that, and so on. And I don't know, launch billing flows and consumer sync are just counterparts of what were defined in the interface before, so no surprise there. So to sum it up, like, there's good things and bad things about the play billing library. And I would say the good thing is that there's less chances of errors for us, because we now have a default implementation that we can use to interact with this service in a nice way. So we no longer have to copy-paste code to, I don't know, look at weird samples or anything, look at Stack Overflow. It's just, that approach is just nicer. And also, it comes with updated samples. So long gone are the days where we had to look for trivia drive. Well, actually, now we have trivia drive 2, so it's not much of an upgrade. However, it's interesting because like, they use the same example using both the InApp billing version 3 APIs and the new play billing library. So you can actually compare the two implementations and decide for yourself if it's worth using the library or not. Spoiler, it is. So it's very nice, and also it comes with support with multiple platforms. So if you target, for instance, Android Wear or Android TV, now those are supported out of the box. So that's a good plus. And I mentioned the better documentation. So the samples now come with a page that tells you precisely what you need to do to get the app running. But also, the play billing library has a proper reference documentation now. So finally, when we want to know more about the billing client, we don't need to, I don't know, read the source code, which is fine, but it takes time. We can just go to documentation, and it's just well written. However, there are things that I consider, I wouldn't say bothersome, but like could be better, if you allow me. So the first thing is that it's not open source. So I was hoping that since, I don't know, Android KTX, for instance, some of you may be familiar with, it's like the Kotlin extensions for Android. That is open source, so Google accepts contribution from the community, which is super nice. I was hoping that there could be something similar to this for the playbilling library, but for now it's not the case. And the other thing is that I believe this, the way the playbilling library exposes its methods is not really streamlined. And what I mean by that is that if your application makes use of the reactive framework or the reactive approach a lot, then it means that you're going to have to, since like there's many asynchronous callbacks here and there that you need to then, I don't know, do something with, it means that you're going to need to wrap them into, I don't know, emitters or subjects or whatever you need to do at that particular time. But this means that you, first of all, you need to do it yourself. And second of all, you need to merge, ideally, all these separate streams into one single stream that you can then subscribe to so that you can create kind of like a unidirectional flow. So to have less chances of making mistakes on concurrency states for your app. And there are, since this is a nice community, there are already reactive extensions on top of this library, which is super nice. I think the buffer engineers did something like the reactive extensions for playbilling library. But yet again, they essentially just wrapped everything into emitters and observables, and they keep the streams separate. So it's up to you then to unify them and provide a single stream if you want to, if you think it's sensible, of course. So let's picture this for a moment. Let's go back 1 year ago, and let's imagine this Android engineer that is hired by a company, and said company says, OK, we're going to start exploring the in-app billing environment. So can we please do some explorations on that? And then this engineer says, OK, I'll do it. And then after 4 months, when this engineer is done, Google releases the playbilling library. Then this developer would say, oh, I really wish this library came out 4 months ago, actually. And as you might have guessed, this developer is me. And it was in June. So I was already done with the implementation of this exploration. And suddenly, just like I don't know, a week after I was done with the implementation, Google released this. And I was like, oh, really? Like, just now? Couldn't have you given it to me 4 months ago? But actually, this is a fun thing. But at the same time, so we had to make a choice. We had to do this exploration, and we were conducting it in parallel between Android and iOS. And iOS, unfortunately, well, I mean, fortunately for them, unfortunately for us, has the upper game when it comes to in-app billing. So the APIs they work with in the framework are much better. The environment for the Sandbox is much better, is much more reliable. So it's easier to use and faster for them to do quick prototypes. We wanted to keep up with them because we wanted the exploration to last the same amount of time for both platforms. So we needed to come up with a way for us to speed up the integration of this exploration. And we decided to go for an open source community-provided implementation of the in-app billing version 3 APIs. And we chose this one. It's called Android in-app billing version 3, so not the fanciest or the most original name. But then again, it did the job perfectly. It still is, I think, probably the most starred library for Android when it comes to in-app billing tools. And yeah, it's open source. It was actively developed at the time, so when the playbilling library wasn't existing. It was a good wrapper around the bare calls of using the AIDL interface, so we didn't have to do many of the things ourselves. We could just rely on this library. And they handled already most of the edge cases that we could think of at the time. So it was just faster to use this library and to rely on the community to help us into this task. And we succeeded, so the exploration actually lasted the same time, so we call this a success. However, if I had to implement everything right now for in-app billing in a new app, or if I had to migrate, I would definitely use the new library announced by Google. Like, just it's a no-brainer at this point. So, yeah, we essentially cover the different ways that we have to implement in-app billing on Android, and it's not really that difficult. But what about testing? How can we test in-app billing on Android? That's a whole separate concern that we need to take care of. And you could ask yourself, oh, yeah, but why testing? please, no. Like, you know it's important to test. You know you should be doing it possibly in an automated fashion, or you still need to do it manually when you're doing the integrations yourself. So you know it's important. So let's just move on and see what tools do we have at our disposal to do this really nice task. So we have 3 tools, basically. The first one is called static responses. The second one is called real purchases. And the third one is, well, fake purchases. Where by fake purchases, I mean it's real purchases, but we use fake money, so we're not getting charged for anything. And let's start with static responses. So it's very simple. Whenever you want to purchase a product, you use a product ID. So you say, OK, in a billing service, I want to buy this product on behalf of the user, and you provide the product ID. But actually, you can use some reserved product IDs that start with android.test.something. And what happens is that whenever the billing service receives this request using this reserved product ID, the service replies with an automated response that is exactly the same every time you trigger this method. We're going to see the list in a second. So yeah, the response is automatic. It's always the same, so you can reliably test all the different states in your app, or most of them. And especially, this is a really good advantage. You don't need the application to be published on the store to use those reserved products, which is amazing when it comes to early prototyping. So you can just, I don't know, throw something together, use the reserved product, see the outcome, repeat. This is the list. So we have 4 of them. One is purchased, the other one is canceled, and we have refunded and item unavailable. So it's pretty easy, pretty straightforward, and it's a great tool, really. Except there's a caveat, which is it cannot be used with subscriptions. So we need a different way, and that way is using real purchases, which is cumbersome because it requires the application to be published in the store. It doesn't matter the channel, so it can be internal, alpha, beta, or production, doesn't matter, but it requires the app to be there. And it's the real deal. So if you're going to press the buy button, you're going to be charged with actual money. So it's not fake or anything. And it's incredibly cumbersome to set up. It's like really frustrating. But we are good, diligent developers, so we're going to go through each and every step, maybe. And let me guide you through. Like the first one is your app needs to be published. So drafts are no longer supported. The second point is we need to have an APK published in one of those channels that we mentioned before, alpha, beta, production, internal, and that's it. Then the APK you upload to the console needs to be the same one that you use for testing. So like same version code, same version name, same signature for the certificate. And then there's this, and then there's this, and then more of that, plus that one, and that one as well. So you can see it's an awfully long list of things that you need to check before you're actually able to say, okay, my real purchases are working for everybody. And it's really mental. And it's not like this list is published somewhere officially in the documentation. Like the documentation, the official one covers maybe 6 of these points here, maybe 7. But everything else you need to figure out by yourself, by just looking at the internet, looking on Stack Overflow. And actually, it took me quite a long time to figure out everything. So whenever something is not working, it's not like you have meaningful information to debug the issue. You just need to, I don't know, Google it and say, oh, actually, I cannot purchase the item I'm trying to purchase is unavailable. What do I do? And actually, this list is super useful to get it up and running as fast as possible. So useful, at least to me, that I wrote an article about it. It's called, I don't remember, I think it's testing in a purchase on Android. You can either take a picture or the slides are going to be published anyway afterwards, so as you prefer. I hope it's going to be useful to you as well, but it's really cumbersome, and it's nice to have a place to say, okay, I can really go through a checklist one by one and say, okay, this is covered, oh, this is what I'm missing. And the testing setup to make everything working is, again, really long. So this is a screenshot taken from the GitHub page of the Trivia Drive version 2 sample. And as you can see, it's still very long. And in order to prepare for this talk, I was going through the setup myself just to make sure everything was according to what I remembered and what I was doing 1 year ago. And actually, it took me almost 1 hour and a half to get everything up and running, like creating an application on the console, released properly with the proper certificate and so on. And imagine if you have to do it on your own without any guidance, it's just very, very time consuming. So not something that I recommend, but you need to know that this is cumbersome and you need to allocate the proper time for it. And the last thing that we can make use of is fake purchases. And essentially, when you do a fake purchase, you become a licensed tester. So you whitelist your email, like your Google email address, so that you become one of these. And what happens is that no money circulates. So it's what is like the closest thing to an actual purchase in real life. However, there are differences. The main difference is that there, especially for subscriptions, there are constraints in both duration and renewal times. And this is fairly new because before, I think this was introduced in February or enforced in February. So before, whenever you were doing a test purchase for a subscription, this subscription was lasting for 1 day, just 1 day every time, and it was renewed automatically without any limit. So this was also a nice tool that we could use to give away subscriptions to our, I don't know, most loyal testers or some of our users maybe, or our family members, whatever you can think of. And this changed recently because, of course. And so now the constraints are as follows. There's a test duration tied to the original duration of the subscription. So for instance, if you purchase a subscription that originally lasts 1 week or 1 month, if you do the test subscription one, it's going to last for 5 minutes. And the longest one, which is the yearly one, is going to last for 30 minutes. And this is just for the duration part. There's also the renewal part. So every time this test subscription renews, it is automatic, but it can only be done for 6 times in a row. So you can go from a minimum of 30 minutes if you purchase the shortest one to a maximum of 3 hours. Yeah, if you purchase the 1 year one. And yeah, it's convenient. Yes, because then you can test on a faster pace, but it's also annoying for the thing that I mentioned before. So we can no longer give away subscriptions to our most loyal testers. One really, really cool tool that we can use is the New York Times register library. And so what this library is and does is actually a fake implementation of the in-app billing service. So instead of relying on the Google one, because, I don't know, we want to automate our tests and we want to make the testing environment as reliable as possible. So no variables, no conditions, something that we can reset every time we want. Actually, we cannot do it because it's tied to the Play Store and it's tied to the Google account that we need to set up on the test devices or in the emulator and so on. So this is actually super useful because it mimics precisely the implementation of the Play Store. But actually, we are in control of what happens. So it's configurable using JSON, like a simple JSON file that describes all the products that we want to make available and to what price and to what duration and so on. So everything is fully configurable. And it even comes with a companion app that we can install on the device, like a test device for QA engineers or QA testers, so that they can, from within the device, they can configure and customize the behavior the way they want, which is insanely convenient for testing purposes. And it removes all the existing limitations for subscriptions that Google imposes. So super, super nice. And the outcome is, of course, integration tests can be run in a safe way and in a meaningful way, which is really, really amazing. And we can see 2 screenshots just so that you get the idea. They even went ahead and replicated the same dialogue that is usually from the Play Store. So it looks like we're using the Play Store, but we're actually not. And you can see register on the top left, on the bottom left corner of the dialogue. And the companion app is very, very basic, very barebone, but actually gets the job done. So props to them. Really, really nice. Again, everything looks beautiful. But there's a caveat. So unfortunately, it's not yet compatible with the Play binary library that Google just announced. This is because of the way both the Play binary library and register work. So they essentially try to wrap the service, but they cannot do it at the same time, so they're not really interoperable. The good thing is that register is open source, so you can go ahead and contribute to that and submit a PR if you want that done in just faster. Then I'm gonna talk a little bit about A/B testing price points, and there's a note of warning here because actually it's not really supported by the platform. So then why am I talking about it, right? Well, actually, I'm talking about it because it's something that you would ideally do in another environment that is not mobile. So you would want to get to maximize the revenue that you can generate, right? However, for mobile especially, if this is done in a wrong way, it can lead to disastrous results. Like users are going to be upset. You're not going to be in control of what happens. You may end up in, I don't know, charging the user money, but the user cannot really take advantage of the subscription. So it makes sense for it not to be available to a wide audience. And it's, yeah, again, very complicated to handle. And yet, can we go back to the example before? So there's this developer, which by now you know it's me, and started working for this company. And this company wanted to explore the InApp environment. And at some point they say, oh, but it would be a really nice to have if we would be able to A/B test price points on both Android and iOS. And me and this colleague of mine, we said, well, that's actually not supported by the platform. So end of story, right? But actually, at some point, we had this moment of revelation. There is something we can do, actually. And yes, this, again, it's me a few months ago. And we devised a way of making that possible on both Android and iOS. It's a testing infrastructure in and of itself. And the way it works is as follows. So we decided to create the same products in both consoles, so the Play Store one and the App Store one, same identical products. These products use the same identical product ID, but the product ID is very special because the way it's written is semantically meaningful. So it means that the name, how it's structured, it means something, so it can be interpreted. And we deliver this product IDs, these meaningful product IDs, using a custom configuration. So we remotely control what the clients are going to be displaying at a given time using a configuration and delivering what product IDs will be fetched by the application. And this is great. Like, it was a super nice achievement because actually it makes it possible to test different price points on both platforms, and not only possible, but super easy. It literally just takes to change the configuration file to issue new products to the user. So it was unbelievably cool. And the fact that you rely on one single configuration file across both platforms makes it even better. But even better than that is that we use the same code to interpret the configuration file and to decide to instruct the clients what they should do. And this was done using the Kotlin multi-platform project. So we already had that in place for other things, and we decided to extend it by adding these premium capabilities. And so the code is all written in Kotlin, and it can be used on Android directly, so just without any effort. And iOS uses it, use the JavaScript compiled version from the Kotlin sources, but the tests are just written in one single place. So it's amazing. You test it once, and it's valid for both platforms. So this was really, really cool. And it's flexible to a point where you can really do everything if you really want to. However, again, there are downsides. It's very, very complicated to achieve. Like, it didn't take us very long to implement, to be honest, but it takes a long time to figure out all the possible situations that can arise by using this, this powerful tool. And again, it's a powerful tool. So, with great powers come great responsibilities. And that's precisely the point. I'm not even joking. It's like you need to be careful about what you do because you risk upsetting the users. So luckily, the company was really sensible on this topic. So they were really careful about using this, and they were able to try everything they wanted to. So the requirement was fully covered. I'm going to talk a little bit about monitoring. The Play Store console is a great tool for monitoring your revenues and your subscriptions and your in-app purchases. You can use two main tools. One is the order management window, which is in the very main homepage of the Google Play console. And the other one is a per app section that is called financial reports. And so for order management, it's very easy, actually. Like, as soon as an order comes in, it's going to be displayed here. And you can say at a glance information like, oh, this is the order ID. It's a test order or it's a proper order. This is how much we charge the user for. This is the product that the user bought to this date and the status. And if you go into more details and if you click on one of them, you can see, I don't know, more details on the price. You can see precisely the sequence of operations that were done to get to that particular state. And you can also have actionable controls, like you can cancel the subscription on behalf of the user, or you can refund the user in case something went wrong. So it's a really powerful tool for customer support, for instance. And then we have the financial reports section where revenue lives. And here, like, you have a really nice chart of the trend of all your sales. They're broken down by product, so you can see which one performs the best, which again is really nice. And the Google Play console all around can answer all of these questions, like how are your subscription performing over time, or why did a user cancel your subscription in the first place? So it's a really all-around great tool for monitoring that you should be checking more often than not. And we're moving towards the end, so I'm going to talk a little bit about the limitations, because I've been working closely with an iOS engineer, one of my colleagues, so we were able to compare the differences between the two environments. And I still believe that iOS has the upper hand in this case, because it feels like all around there's more control over what you can do or over what informations you can retrieve. And the Sandbox environment is amazing, so it's super reliable, and it's actually, whatever happens in the Sandbox environment, you can be sure that it's going to happen in the real world. And they have all-around better promotion tools. And on Android, really, what bothers me right now is the subscription support. Like, there's no promo codes for subscriptions. There's not really an easy way of testing, because we said we need to go through a cumbersome setup that takes a long time. And discounts are only available if you use the web API, which is, again, something that you need to do on top of all the work that you need to do anyway. So it's really, it feels like it's neglected, and it's not a good feeling. However, there have been so many improvements over the last years that it's nice. And I think Google is playing catch up with Apple, and in a year's time, it's going to be probably at the same level or even better. Yeah, so this is all for me. So if you have any question, I'll be happy to take them, or even either now or later. And you can find me on Twitter if you want to ping me. And thank you.